All right, so today's notes we're going to be looking at understand it. I call these notes understanding standard deviation. We're going to be less focused on calculating standard deviation because, to be honest with you, for some of you guys that end up taking a statistics class, you might not have to calculate standard deviation by hand. You might just put it into a graphing calculator, or you might just use some kind of software. So you might not have to do that process. I figured it was worth showing you guys just because you might have to do it depending on your statistics professor if you do end up in a stats class. But honestly, there's a good chance you might not have to do that necessarily. So just keep that in mind. It might not be that bad if you're in a stats class in terms of all the calculations. You might be able to use software. But a lot of you guys will end up in a stats class. Like I said, if you're planning on doing anything in the medical field, like if you're planning on going into nursing, or if you're thinking of going into like psychology, or you want to do something with like social work, there's a good chance you'll end up in a stats class because any kind of field where you're going to be looking at like research studies or conducting studies, you're going to want to have a little bit of a statistical background. But without further ado, let us jump into these notes. A couple definitions. If you see these symbols, this a lot of times in statistics, you're going to see they use a lot of Greek letters. But this is mu, or basically the Greek letter for M. If you see this Greek letter mu, that's the mean of your data set. It's technically the population mean. I don't want to go too much into this. If you're in a stats class, you might talk more, but basically population means if you have your entire data set, you can calculate the mean. If you remember the X with the bar, that's when you have a sample of your data. So if you don't have like all of the data, because some things it's impossible, like I can't have the height of every person in the world, but I can have a big sample size, if that makes sense. This sigma, or this weird looking kind of O with kind of like a hat or a little like tail on it, that is your population standard deviation. It's similar idea. If you have like your entire data set, this would be your population standard deviation. So, but basically for the purpose of this class, we use your mean, sigma is your standard deviation. One thing in statistics is a lot of times when you're collecting data, it's going to fall into a category of fit in a normal curve. A lot of times when you're conducting studies on anything, it's really easy to think of examples related to like medicine or just people in general, like the height of people. If like, for example, I know this class is small and I can't see you, but if I collected the heights of like all of the seniors, let's just say like the entire senior class, most of your data is going to fall towards the middle. Like most people are going to be close to average height, right? But you're going to have some extreme cases. You're going to have some like basketball players that are like way up there. They're going to be over here. And you're going to have some people on the shorter side that are going to kind of fall on this side of your curve. But most of the population, like most people, if I just pick someone at random, they're going to be close to the average. Most people in terms of height kind of, they're not that too far apart. But you're always going to have extremes on both cases, or you're going to have people that are kind of taller, or you're going to have people that are kind of shorter but not that short. Like there's always going to be a range of people, but usually a lot of data sets you're going to see they kind of fall towards an average. And this is the same with like IQ test. Most people are going to score average, but you're going to have people on the high end like geniuses. You're going to have people on the lower end. But I mean, and I don't really put a lot of weight in the IQ test, but that's like a common example where you would see a normal curve. Like all these standardized tests, like the ACT and stuff, like most people kind of fall towards the average on the ACT, which I think is like a 20-ish. But you're always going to have some extreme cases where people score like a 36, or you're going to have really low cases where someone fell asleep during the test and they got like a 4 or something. So keep that in mind with stats. So sorry, I know I'm babbling a little bit, but hopefully that gives a little bit of context. But what we're going to be looking at with this normal curve is basically when you make your normal curve, you always put your average in the center, and then you add your standard deviation as you go this way. Like this would be 1 standard deviation to the right, 2 standard deviations, 3 standard deviations, and you go 1. And then on the other side, sorry, you go down standard deviation. So this would be down 1 standard deviation, down 2, down 3 standard deviations. So the first thing we kind of do is we kind of categorize different pieces of our curve. And I'll try my best on this iPad, but between like here where it says -1 in between where it says 1, we consider if you fall in this part of your data set, you're considered average. So you can either, like, I know you guys don't have this in front of you. I would say if you do have this printed off, you can either label your picture or you can write it down here. But if you're between -1 and 1 standard deviation, you're considered average. Um, and this would be most of your data. A lot of times, like I said, if we're looking at the heights of people, most people are going to kind of fall in this average range. Most people, especially when you're looking at like physical characterizations, most people tend to be pretty similar to each other. But like I said, you are going to have extreme cases. If you're between, so on the other hand, if you're between 1 and 2, and just a heads up, if you are in a stats class, they might use slightly different vocabulary. I've seen different textbooks say different things, but if you're between here and here, we would say you're above average. So I'm going to abbreviate that AA, but we that would be considered above average, or just maybe if we're talking about height, you're a little bit taller than most people in your class, but you're not like a giant either necessarily. Between 2 and 3 standard deviations, I usually say that this is way above average. So this would be like your crazy basketball players that are like almost 7 foot or kind of approaching that. Like they're way taller than most of your population. Similar on the other side of our normal curve, like between -2 and -1 on the bottom there, that would, I usually call this, we call this section below average. And I'm just going to abbreviate average, AVG. If you're between -3 and -2, we say you're way below average. So similar to the other side, except you're smaller. So we say it's way below, like it's less than the average instead of above the average. And then every once in a while, you'll have those really, really extreme cases. Those are going to be considered outliers. And you can, if you look at your percentages, you can see this is a very, very, very rare case in your data set, like 0.515%. So that might be like Shaq, like Shaquille O'Neal would be an outlier, like over here. I don't know. And then you might have, I don't know, like a famous little person, actor, or someone like would fall over here, um, for example, if we're using height as our example. So, and like so this last box, more or less than 3 standard deviations, you're considered an outlier. And I know right now this might not make a ton of sense. Like, what is that -1? What is all? We're going to make a curve, and you'll see that basically once you get your curve made, these are kind of the labels you're going to be using. Like, but so like between here and here is going to be average. Between here and here, we would say it's above average. And you can kind of notice like the percentages. This is only if your data follows this normal curve. But like I said, a lot of data sets will. It'd be probably more than you would think a lot of times. And there are things you can do to kind of make your data set kind of fall into this pattern. There's like different kind of ways you can manipulate it. But so this is kind of like, I would say this is how you kind of categorize your data. So if I said someone fell at this number, you could look at your normal curve and see what category they would be in. Another rule, this is called the empirical rule, or most books are going to just call it the 68, 95, 99.7 rule. What this rule tells you is, and I'll try my best, let's use a different color. If you're between 1 standard deviation, like on both sides of your mean, let's see if I can write this. Okay, so what this tells you, if you're between 1 standard deviation, or between -1 and 1 standard deviation, let me actually, one second, I want to see if I can make this smaller. Perfect. Okay, sorry about that. So let me write this so I have a little bit more room. So sorry, the 68, 95, 99.7 rule. If you're between -1 and 1 standard deviation, so I'm just going to abbreviate standard deviation SD. That's going to have 68% of your data. Like if you look at this curve between -1 and 1 standard deviation, 34 and 34, that would be 68% of your data. So most of your data is going to be between 1 standard deviation on both sides. Between -2 and 2, like so basically 2 standard deviations on both sides, you're going to have 95% of your data. Like if you look at, if you're between -2 and -2, if you add up these percentages, you're going to see 95% of your data. Pretty much all of your data is going to be between 2 standard deviations on both sides. And I know this is sloppy. If you're between 3 standard deviations, so like between -3 and 3, that's going to be 99.7% of the data. So pretty much all of your data, except like extreme outliers, will be between 3 standard deviations. So that would like be represented from here to here, if that makes sense. So these are kind of like the two big concepts. I kind of wanted to look at an example to see kind of, well, like even if you're like sort of understanding this, like what's it going to look like when we're using this like in problems, or like how's it going to be presented to you? For this example here, and I will post like these notes and I'll handwrite them, or I'll make sure they're neater. But for this example, it says when reading the results to an intelligence test, IQ test, you have, if you remember the symbols from the beginning of the notes, this is mu, or your mean, and your standard deviation is 15. They want us to graph our normal distribution chart and then answer these questions. So when you make your own curve, you always put your mean in the center. Like your average always goes in the middle. And the nice thing about these problems is we're not going to have to calculate it by hand. So we won't be calculating standard deviation by hand quite as much. I might throw it every once in a while, but most problems I'll give you the standard deviation. So when you label the rest of your curve, the standard deviation is what you're going to go up by and what you're going to go down by. So like in this direction, you add 15. So that would be 115, 130 plus 15 would be 145. And then when you go the opposite direction, you subtract 15. So 100 minus 15 would be 85. 85 minus 15 would be 70. 70 minus 15 would be 55. Did I do that right? Yeah. Yeah. I don't know why I just felt like my math was off, but it's not. And one thing I like to do is I like to label my categories. Remember, between -1 and 1 is your average. Between 1 and 2, this would be above average. Between 2 and 3 is way above average. Between -2 and -1 would be below average. And then -3 to -2 would be way below average. And then anything past those would be outliers. So I would label this if I were you. I mean, you don't have to, but I think this will definitely help you answer a lot of questions if you put those labels in. So it says what score range would be considered average. So average is from here to here. So the range would be from, I'm just going to write it below, it would be from 85 to 115. So if you got 85 to 115 on this IQ test, you would be considered average. And some might break it more than that, but basically, if you're between 1 standard deviation, that's pretty normal in terms of like a test. What score range would be considered way below average? So way below average based on our labels would be from here to here. So that would be 55 to 70. So if you got a 55 to 70 on this IQ test, you'd be considered way below average. And then the next question, it says, how would someone feel if they got a score of 147? So that would be somewhere over here. So that would mean you scored incredibly well. So you would probably feel good. I mean, technically, I mean, if you put a lot of weight into an IQ test, that would you would be considered a genius. Um, I don't know. IQ, I mean, doesn't always correlate necessarily to a ton of success. There's plenty of geniuses out there that I don't know. I mean, they struggle if they're like I don't know. Like so, I don't know how much IQ tests really demonstrate. I'm sure there's studies. I mean, I'm sure there's more to it than just my speculation. But it says for the fourth one, it says list the score that would be considered above average. So above average is between here and here. So any score between 115 and 130 would work with this. For example, 120 would be an above average score. You could say 117, you could say 125, anything between 115 and 130 would work. So that's kind of the idea. That's it for today's notes. But basically, when you label a normal curve or a normal distribution, you always put your mean in the center, and you're going to use your standard deviation to add up or down. And then based on how many standard deviations or where you fall on your curve, we can kind of categorize it into these different things. And like I said, just keep in mind if you are in like a college class, they might use slightly different labels, or they might not even put labels on it. But these should be kind of a helpful way to think about it. Um, but basically, depending on how many standard deviations you are away from your mean, that's going to tell you some information. It's not always good or bad. Like if we were looking at blood pressure, for example, if you were way on the high side, that's not a good thing if you have super high blood pressure. But a lot of times being on the other side is not good too. If you have super low blood pressure, that's also not good. Like, so especially with medical examples, usually you don't want to be on one extreme or the other. It's usually good to be towards the center for a lot of things, but I mean, obviously it depends on the context. So that's one thing with these. It's definitely important to read the context of the problem to see what it's talking about, because depending on what it's talking about, that's going to change necessarily how you answer some questions. If they're kind of asking for more of like a what does it mean kind of thing here or there. But I'll stop babbling.